Too much math, too little time. All right, so where are we? We are finishing up P6.
No, we're on P7.
Oh, wait.
P7.
Oh, that's right. That's lunch. Yes. We are ready now. We're ready for E. Okay, good.
Yeah.
Okay. So what do you think about problem E? It's pretty much like the last couple we did, or the last one we did, I should say. What do you think about this? What should we do? Subtract 20. It's a quadratic, it's an inequality. We definitely want to have a 0. Okay. We know what we're going to go to a number line, right? We know we're going to have a couple dots on that number line, and they're going to be colored in dots. I just need to figure out where the dots are. And I've got options galore. This is a quadratic. If you want to know the zeros of a quadratic, you can complete the square. Yucky, yucky, yucky. Right? Why am I saying yucky, yucky, yucky?
You have to divide by 2.
Divide by 2, I'm going to have to deal with a fraction. Definitely doable, but if I have other options, I'm not going to do that. What else can I do? Quadratic formula. Absolutely. What else can I do? Factor it. I think this factors. It might be more trouble than it's worth. Let's see. No, I think it's pretty handy. I think 5 and 4 will work. Because remember, I need to multiply to 20, and then I need my outsides and insides to combine to 3. So that'll give me an 8 minus a 5. Okay, good. So this is going to be faster every time. So if you can factor it, that's the fastest way. Because now I know where my dots are. My dots are at -4 and 5 halves.
Yeah.
Now I can't even remember. Did I share the super secret thing with you yesterday? If it's a less than, if I have 2 dots on my number line, and it's a less than, we're going to be shaded in between them. Now, if you don't trust me, you don't trust that, you forget that, you don't want to do it that way, you can always pick a number, plug it in, and see if it works. Because if you picked, like, let's say we picked 0. If we plugged 0 into this equation, it would say -20 is less than 0. Is that true? That means wherever 0 is on the number line, that section works. Well, in here? Yeah. So you can always check. But the minute I see a less than with 2 dots, I'm going to shade in between. My answer is bracket -4, bracket 5 halves. Good? Yeah. Marin?
So I understood, like, for the absolute value ones, how that represented distance, but how does this one like, how does this equation represent the distance?
I am looking, I'm not doing distance because absolute value is distance. This is not an absolute value problem. I am looking for numbers that I can plug in and get a negative result.
Okay.
Negative result. All right, what's different about this guy? It's got an x cubed. Now, the big difference there is we're going to have 3 dots. This number line is going to have 3 dots. Every x gets a dot. So when there were 2 x's, we got 2 dots. I'm talking about in a polynomial. So in a polynomial situation, if there's x squared, 2 dots, x cubed, 3 dots, and so on. So I need to figure out where the dots are. What do you want to do with this? Take out an x. Can I factor my little quadratic that's left?
Yeah.
How does that factor?
X minus 6 and then x plus 5.
Minus 6 plus 5, that's an easier one because there's no coefficient out there. All right, so here's my number line. My dots, clearly I've got a dot at 6. clearly I've got a dot at -5. Where's that third dot? 0, absolutely. What's attached to this x? 0, right? Nothing attached to it, so the dot goes at 0. 3x cubed, 3 dots. Now, the rule, I shouldn't say, the observation that the less than is going to be shaded between the dots only works when there are 2 dots. Because in a 2-dot problem, you're either shading between or you're shading out. Now we got lots of different things that could happen. So let's choose a number, any number, anywhere. What number do you want to choose? Can't be one of these. It has to be a number that's no dot. Who in the world picks negative numbers? I mean, you can. But why make my life hard? How about 1? What a great number. 1, right? 1 is a great number. Now, I don't care. -6 will work. So will root 17 if you're into that. Lots of numbers will work. I mean, any number except these will work. I just want to be as lazy as possible. So I'm going to try 1. All right? Now, 1 is here in this little area, right? With 3 dots, we now have 4 areas to be concerned with. We are working on this area because we're trying the number 1. Now, I'm going to put 1, and I don't care where you put it. Sometimes it's easier to put it in the original. Sometimes it's easier to put it in the factors. Wherever you want to put 1 in, I want to know what you get out. So if I put 1 in, it looks like I get -30. Let me double check that now. If I put in 1, it looks like my answer is -30. Is -30 bigger than 0? No. So that means this chunk is not part of my answer. Okay? This is not. This does not work, so I am not going to shade this in. Another little hint for you. As long as the problem is normal, and I'll talk about what not normal looks like, but as long as the problem is normal, your shading will alternate. So the minute I realize that this one isn't going to work, then I know this one is, and this one is, and this one isn't. Your shading will alternate. Unless it's weird, and I'll explain that in a second. So, we picked 1. We could have picked lots of numbers, we picked 1. The area, the chunk of the graph where 1 is, didn't work. That means it's not shaded. That means the 2 pieces on either side of it are, because the shading alternates. Shade not, shade not. So my answer is the interval from -5 to 0, or the interval from 6 to infinity. Now, what does a problem look like? What happens in the problem if it's not normal? Lucy?
Wait, I had a question. So when you say the shading switches up, just means it's like every other?
Yep.
Okay.
Yep, that's what alternate means. Back and forth, back and forth, back and forth. Yep. So, what if 1 had worked? If 1 had worked, then I would have shaded this, skipped that, and shaded this. Okay. When this strategy doesn't work is when you have a problem with something like this on it. When one of your factors is repeated. When you have a repeated factor, then all bets are off. And you have to do it, what we did with 1, you have to do it with every section. So, if that, let's say that had been squared, then I would check this, it didn't work. Then I'd have to turn around and check this one by picking 7 or something, and then I would have picked -3 or something, and then I would have picked -6 or something. If you have a repeated factor, then you're going to check every single region. There's no like hint I can do. If there's no repeated factor, you have one of these, one of these, one of these, then every other one. All right, good deal. Now we're gonna do the same thing on our calculators. Emma, did you have your hand up a while ago? Oh, I thought you did, okay. All right, now we're gonna start with our calculator. So we're doing basically the same exact kind of problem, but now we're letting the calculator do the work. So let's make sure we have a standard window. So again, you go zoom 6. That will give you a standard window. Whatever equation you have in there, get it out and put it in this one. X squared minus 4x plus 1. When you graphed it, no surprise here, did you get a parabola? Of course you did, because x squared graph as parabolas. It looks like something like this is what mine looks like. When we did these before, we were looking for the solutions to the equation. So it wasn't a greater than 0, it was an equal 0 when we did it before. So we would find this point and this point using second calc 0. We're going to do exactly the same thing, only we also have to pay attention to the fact that we want to know where it's bigger than 0. So wouldn't that be all of this and all of this? So our answer will end up looking something, it'll be an interval like this, 2 pieces. All right, let's go ahead and find those zeros and set up your intervals. If you've forgotten how to do this, lean over to your neighbor, because I'm sure your neighbor knows. And let's round off to the 100th. I got 0.27.
So it should be negative.
Oh, I got positive 0.27. I think it's positive 0.27.
That's what I got.
Oh, okay, I thought somebody said negative. I probably heard it wrong. And then for this one, I got 3.73. All right, now remember, you're looking for x values. So you want all the x values of this shaded part. So don't we want everything left of 0.27 and right of 3.73? So negative infinity to 0.27, we'll bracket that one, and then 3.73 to positive infinity. Everybody good? All right, let's get the next 2 done. Probably be lunchtime. Oh, and we can start on word problems, great. All right, so here we go, next one. And anticipate that during lunch. Whoa. This happened in a homework problem. It was totally accidental on my part, but it happened, and we have to deal with whatever happens. Some of you dealt with it fine. Some of you shot and missed. What happens when I graph this thing, you guys?
There's no zero.
There's no zeros. Now, that alone is not an issue, okay? What's the issue is, I am trying to find parts of the curve that are less than 0. Are there any parts of that curve less than 0? So, I need you to understand, we don't say empty set because it doesn't intersect the x-axis. We say empty set because no part of the parabola is below the x-axis. So, had our parabola look like this, there's still no x-intercepts, but that answer would be everything. And by the way, we write everything like this. right? So this one would be everything in that scenario. This one is nothing. Got it? Okay, all right, one more.
Wait, so what do you want to
So for this one, you put empty set, there's no solution. So you can either put empty set or you can write no solution. Because there are no parts of the curve below the x-axis. Nothing's negative in that parabola. Okay, so try the next one, which is a cube. Doesn't change a thing except the shape. Shape will be different.
I don't want to do very long, I'm wasting my lunch.
There's no one. Are you ready?
I'll only want that. Well, then we can
Now, this problem, I know you all typed it in, but with the window that we had, it was a little tough to see exactly what was going on. So, I just played around with mine for a minute, and I changed my x's, my x-min, I manually changed it to -5, and my max to 5, and my y-min to -1, and my y-max to +1. I manually changed those, trial and error, playing around. If you make that change, or a similar change, it becomes a little more clear, I think, what's going on. Did you get something that looks like this when you change the window? This part here was confusing to me with the original window, so I wanted to expand it. So I altered these mins and maxes, so I see this picture now. So, there are 3 zeros, would you agree with me? We know how to find those. The zeros are not alone the answer to the problem though. We want to know where the curve is above 0. So your answer will be this right here and this right here. Would everybody agree with that? That's the part of the graph that's above 0, positive y values. All right, let's find them. Remember, if you can't see your cursor, you know where it is because the calculator tells you.
run trails and hope you don't break your ankle.
All right. If you got them, look up here. Did you get -1.62, -1, and 0.62?
Yeah.
So what is our answer? Please don't put that in the answer blank. We're not looking for the zeros. We're looking for where it's greater than or equal to 0. So that will be where? So -1.62 to -1 bracket right in there. Or union symbol, or bracket 0.62. That corresponds, remember the graphing picture, or on the number 1 picture we did, we had these 3 dots? And remember how one section was in between and the other section was the end? That corresponds to that exactly. See how it's kind of alternating sections there? Yeah, perfect. Okay, all right. Oh, let's wait 1 minute, and then I will have you back at 49. All right. So I'm gonna wait 1 minute, and 49. They'll probably kick you out before that, but you have that time to go to the bathroom,